Hello everyone and welcome to my channel. In this video, we will have the uniform or the rectangular distribution for the probability density functions of continuous random variables. Example number 1. Let x be a random variable that represents the time in seconds a smile of a learner can last. If x follows a uniform probability distribution with a equals 0, and b equals 25, find the probability that x is between 10 and 20. So a uniform distribution has an equation f of x equals c, where c is the height of this rectangle. And the width or the base of this rectangle is b minus a. Our b here is the highest value, which is 25, and the lowest value of x is 0. That is our a. So 0 to 25, meaning to say the smile of the learners, the smiles of the learners surveyed can last from 0 up to 25 seconds. So this one in letter A is asking us what is the probability that a randomly selected learner has a smile that is between or greater than 10 but less than 20. So for a uniform distribution, the total area of this rectangle, since this is a probability distribution, should be equal to 1. And its base is equal to from 0 to 25. So that is 25. So we are asked of the area of this rectangle, that is because this is from 10 to 20. So we can see here that the base is from 10 to 20. So that's 20 minus 10, that's 10. But how about the height? So the height is just 1 over b minus a, because b minus a is 25 minus 0. That is the width of the rectangle, or the base here in this case. And the height, if we multiply the base and the height, the total should be 1. Or the product should be 1. So if the product is 1, then c, or the height here, should be 1 divided by b minus a. And here in this given, b is 25 and a is 0. So the height of the rectangle here is 1 over 25. So here we have a rectangle here with base 10 and height 1 over 25. So the area is 10 over 25, which can be simplified to 2/5 if we divide both the numerator and denominator by 5. So 20 minus 10 is the base, because that's from 10 to 20. How long is this line segment here from 10 to 20? So you just subtract 20 minus 10. And then 1 over 25 is the height of the rectangle here. So base times height. So that is 10 over 25, which is 2/5. So the probability that x is between 10 and 20 is 2/5. Letter B. Find the probability that x is greater than 20 but less than 25. So how does this look like in the graph? So from 20 to 25, so from here at x equals 20 up to here at x equals 25. So how big is this rectangle, or what is the area of this rectangle? The area of this rectangle is also the probability. So the base is from 20 to 25, that is 5. So 20 minus 25. And the height is still 1 over b minus a. So that's 1 over 25. So 5 times 1 over 25 is 5 over 25, or that is 1/5. Divide 5 by 5, 1. Divide 25 by 5, 5. So 1/5. So the probability that x is greater than 20 but less than 25 is 1/5. Another, probability that x is greater than 5 but less than 20. So that's the graph. So from 5 to 20, how long is that? That is 15 units. 20 minus 5 is 15. So 15 times 1 over 25, that's 15 over 25. Simplify that, you will have 3/5. Divide both numerator and denominator by 5. you will get 3/5. So the area of this rectangle is 3/5. That is also the probability. Letter D, probability that x is less than 20. So that rectangle, this one. So the base is from 0 to 20. So that is 20 minus 0. Height is still 1 over 25. So that is 20 times 1 over 25. That's 20 over 25, or 4/5 in simplest form. Letter E, probability that x is greater than 0. It's the whole rectangle from 0 to 25. So that is 1, or 100%. But if you will use the area of the rectangle, that's base is 25 minus 0, and height is 1 over 25. So 25 times 1 over 25 is 25 over 25, which is 1. But you don't need to solve this one here, because if you will see this, probability that x is greater than 0, of course, it's always greater than 0, because it's from 0 to 25. Letter F, probability that x is greater than 7 but less than 17. So from 7 to 17, how long is that? That is 10 units. 17 minus 7, that's 10 times 1 over 25, which is the height. So 10 over 25, divide by 5, both numerator and denominator, you will get 2/5. So the area is 2/5. That is also the probability. Letter G, probability that x is between 12 and 16. So that's how it looks like. So base is from 12 to 16. That's 16 minus 12. That's 4. So 4 over 25. And that is the simplest form. So how do we get this 16 minus 12? That is the base. From 12 to 16, how long is that? So that's 16 minus 12. Probability that x is greater than 25, we don't have a rectangle there, so that's 0. Probability that x is less than 25, of course, is the whole thing. It's 1. Probability that x is 15, that is also 0, because in continuous random variables, in the probability density function, the probability that x is equal to a particular value is 0. Another example, example number 2. The length of time in minutes a person must wait for a bus is uniformly distributed from 0 to 20 minutes. So we have here the graph from 0 to 20 minutes. So our A here is 0 and our B here is 20. So what is the probability that a person waits 5 to 10 minutes? So 5 to 10 minutes, so that is the probability that x is greater than 5 but less than 10. So that rectangle, this one. So what is the area? So we will identify the height first of the rectangle. That is 1 over 20, because that is 1 over b minus a. B is 20, a is 0, so 20. 1 over 20. So our base here is from 5 to 10, so that is 10 minus 5 units, or that is 5 units, times the height, which is 1 over 20. We have 5 over 20, or 1/4. So the probability that a person waits 5 to 10 minutes is 1/4. B, what is the probability that a person waits 8 to 19 minutes? So that is this one. From 8 to 19, how many units is that? That is 19 minus 8. That is 11 units. So 11 times the height, which is 1 over 20, is 11 over 20. So the probability that a person waits 8 to 19 minutes is 11 over 20. Letter C, probability that a person waits less than 12 minutes. So probability that x is less than 12. So that is, for the base, we have 12 minus 0. That is 12 times 1 over 20, which is the height of the rectangle. So that's 12 over 20. Or you can just remember this denominator as the difference of a and b. And the numerator is also the difference of the boundaries here of the rectangle. So divide both numerator and denominator by 4, you will get 3/5. So the probability is 3/5. Letter D, probability that a person waits more than 16 minutes. So that rectangle base is from 16 to 20. So that's 4 units. 4 out of 20, that's 1/5. Example number 3. The duration of time X of baseball games in a league is uniformly distributed between 150 minutes and 225 minutes. What is the probability that X is less than 200? So we have here the graph from 150 to 225. We need to identify C. C is 1 over B minus A. A is 150, B is 225. So 225 minus minus 150 is 75. But for the question, P that X is less than 200, that is this rectangle. So we have, solve for C first, so that's 1 over 75. 1 over B minus A. B is 225, A is 150. So 225 minus 150 is 75. So the height is 1 over 75. And then next is find the area. Area is base times height from 150 to 200. That is 200 minus 150. That is 50 units. So 50 times 1 over 75 is 50 over 75, which is 2/3. Divide 50 by 25, 2. Divide 75 by 25, that's 3. So 2/3. Letter B, probability that X is greater than 200. So we have that 200 to 225, that is 25 units. So 25 times 1 over 75, which is the height. So that's 1/3. Divide 25 by 25, that's 1. Divide 75 by 25, that's 3. Probability that X is between 175 and 200. So 175 and 200. So we have 25 units. So this is from 175 to 200. That's 200 minus 175. That is 25 units over 75. That is also 1/3. So that's it for the uniform distribution, or also called the rectangular distribution, for the probability density function of continuous random variable. Thank you for watching. Comment, like, and subscribe. Bye!